This gas law question is for those who are already mature in chemistry. But as a beginner in chemistry, I will guide you on how to solve this kind of question within few minutes. Now, let's go. Gas X diffuses twice as fast as oxygen. What is the relative molecular mass of X? And the second question is, what mass of X would fill a 5 dm³ steel cylinder at standard temperature and pressure? The atomic mass of oxygen is 16. The molar volume, that is the volume occupied by 1 mole of any gas, is 22.4 dm³. Now, let us face the first question first. It talks about gas X diffusing twice as fast as oxygen. So, it is talking about rate of diffusion and the relative molecular mass. So, there is a mathematical relationship between rate of diffusion and relative molecular mass according to Graham's law. And it states that rate of diffusion is inversely proportional to the square root of relative molecular mass, right? But this time around, we are comparing two gases. Gas X and gas oxygen. So relative molecular mass of X and relative molecular mass of oxygen. Because of that, we can now take ratios of rate and 1/square root of molecular masses. And if you do the mathematics, this is what you have. Rx over RO2 equals square root of molecular mass of O2 over molecular mass of X. Now from here, gas X diffuses twice as fast as oxygen. So the rate of diffusion of X is twice of that of oxygen. So you change Rx to twice of R oxygen. The same thing. You can now see that R oxygen will cancel R oxygen. And 2 over 1 will give us square root of molecular mass of oxygen. Atomic mass of oxygen is 16 and oxygen is a diatomic gas. So you multiply 16 by 2 and you have 32 over molecular mass of gas X. This is what we were asked to calculate, right? So when you have this, you quickly square both sides. And what we are going to have here is 4 equals square will cancel square root. And we have 32 over molecular mass of X. So that when you cross multiply, molecular mass of X equals 32 divided by 4. And that is 8. You see, the molecular mass of gas X is 8. We are going to move to the second question, which says what mass of X would fill a 5 dm³ steel cylinder at STP? Once you hear STP, you remember that at STP, 1 mole of every gas occupies this volume. That is even the essence of giving this at STP, right? And the particular volume was given. So we are going to find the number of moles of gas X that fills this volume. From there, we can now calculate the mass, because mass is equal to number of moles times molar mass. Mass will now give us number of moles times molar mass, which is 8. So we must find number of moles by looking at this and this. Remember, 22.4 dm³ occupies 1 mole. Therefore, 5 dm³ would occupy how many moles? 1 over 22.4 times 5. And we are going to have 0.2232 mole. This is the number of mole of gas X that is found inside 5 dm³. And the question is saying what mass is in that mole. And this is the mass. This is the mole. We multiply it by 8. And the mass of gas X that fills 5 dm³ steel cylinder will now give us the number of moles 0.2232 times 8. And you are going to get 1.79 grams, approximately 1.8 grams of gas X. I hope you got value. If you did, click on like, comment, share the video, tag your friends, follow and subscribe to my YouTube channel.